So this is a continuation of 1.6 in college algebra. This is 1.6b as in boy. We're on page 137. We're just getting ready to start the section on difference quotients. So I've got the graph here from the side panel on page 137 that I want to look at. This is, again, some stuff that you're going to need for calculus if you head that far. So good to get started. Back in section 1.3 we looked at rate of change. We looked at the rate of change from, say, this point to this point, which was basically the slope of this line. Okay, so notice we've got a graph here of an arc, and then we have a line that goes through a point here and then a point here, and that line is called a secant line. Okay, you studied it in circles a while back. You know, a diameter is a secant. Anything that goes through this part of say a circle, one side, and comes out across the other side would be a secant. But we're looking for the slope of that secant. And again, in calculus you'll be using that a lot more often. But what we're going to do is we're going to, instead of call this rate of change the rate of change, we're going to call the ratio, or the slope, which, you know, is a ratio, it's y over x, we're going to call that the difference quotient. Okay, so let's go ahead and look at this graph, and what I want you to get out of this graph is just what these are right here, because we're going to be using them in a formula. Alright, our x value here is how far we came over this far here, and f of x value is our y point to get us to that point. So x, f of x. So we've got x, and when we put x into the equation, we get a y value, or an f of x value, which is where that point comes from. Up here it says x plus h, which means we went to x, we added h, and we got here. So this length here is x plus this length here, which is h. So that's my x point. To get to my y value up here, we went up this far, up f of x, and then we went up another distance here, h. So our function is f of x plus f of h, which is f of x plus h. So that's the y value right there. So the x value, the y value for this point, the x value, the y value for that point. Okay, which is going to end up being helpful to us later on. So let's go ahead and move that over to the side and give you the formula. The slope of the line called a secant line is f of x plus h minus f of x. Now notice, when I look back over here, I've got this y value minus this y value. If you remember the equation we had a while ago that was, I'll put it down here on the bottom left, y minus y1 over x minus x1, and that was the slope, and I also called it the change in y over the change in x. Okay, this formula that I'm going to put right here is basically this formula right here. So we took the difference of the y's, now we're going to put that over the difference of the x's. So the 1x, which is x plus h, and we're going to subtract our other x there. And there's our formula. This is the slope of the secant line right there. Okay, and that's what we're looking at. It's also called the difference quotient. Okay, so when we look at this equation right here, let's go ahead and simplify that. The top, we can't do anything about it. It's going to stay the same. But if you'll notice, we have an x plus h minus x. So we have got an x minus x here. So we're going to get rid of those, and our formula is going to be what I have right there. So if I have a function, and let's go ahead and get rid of this here. if I have a, and let's put this back over h, and that is our slope, or our secant line, the slope of our secant line. And let's look at example 3. It says that f of x equals 9x plus 5. And it's wanting us to find the difference quotient, or the slope. Now, in your y equals mx plus b, you look right here, there's your slope, and you're done. But that's what we're going to get for an answer, is 9. But I want you to use this formula here because later on it's not going to be so obvious that the slope is 9. So let's go ahead and do that. So let's find, first of all, f of x plus h. So we're going to always find this part, then we're going to find this part, then we're going to find this part, and then we'll do the math. So f of x plus h, that equals, and what that means, remember, is wherever we see an x, we're going to put an x plus h in its place. Okay? So therefore, 9, let's see if I can get this to right, 9x plus 9h plus 5. Okay. And we know our f of x is this, so we're going to put that here. And our h we don't know, and that's just going to stay h. So let's put this all together in this formula that I have up here. So f of x plus h is 9x plus 9h plus 5. Our minus f of x up here is going to be minus 9x plus 5. Because remember, right here, that's our f of x right there. So we just take that 9x plus 5 and put it here. And we're going to put that all over h. And we're just going to do the math. So 9x, and then we've got minus 9x there. So really, those 9x's go away. So let's just cross those out. So I guess I can erase that. I have this 9h, and that's going to stay. And I have a plus, oops, I'm sorry, a plus 0 because I've got this minus that distributed to the 9x, and it canceled out with that. It also distributes here, so I have a positive 5 minus 5 here, so that's going to go away as well. So let's go ahead and just have 9h, and I can't erase it, so let's scribble over h, and these h's cancel, and I'm left with 9. So 9 ends up being the slope, or the difference quotient for 9x plus 5. Alright, so knowing that that all works, let's go ahead and do example 4 on page 138. So, let's see if I can erase some of this. Okay, so there's our formula. They give us a function, f of x, and they say that that's equal to 2x squared minus x minus 3. Make that x a little bit better. Okay, so they want us to find the difference quotient. So again, we're going to use that top formula in order to do that, and the first thing we're going to do is find our f of x plus h. So that is going to be, in fact I can't do it all in that top row, so let's put it down here. Wherever I see an x, I'm going to put x plus h in its place. And that first x is squared, and then I subtract it. Make sure you put parentheses here. It's always a good idea to do that. Minus 3. Okay, so when we do all the math, when we take this and do the FOIL method, multiply it by the 2, subtract x plus h from that, we end up getting f of x plus h as 2x squared plus 4xh plus 2h squared minus x minus h minus 3. So we get that whole mess there. Now we have to take our f of x and put it here and put that over h. So let's do that. 2x squared plus. So we end up with this right here. There's my f of x plus h from here, minus f of x. Here's my f of x, so I put it here, and it's over h. And then I'm just doing the math and doing the math and doing the math, combining like terms and canceling where I can and doing all that, and I end up with an answer of 4x plus 2h minus 1. That is the difference quotient. That is the slope, basically, of the secant line. Now, it doesn't look like a slope because you're used to seeing numbers giving you a slope, but in calculus, this is what you're going to end up with, and then you take this answer and you do some other things with it, but that we'll save for a couple years down the road. So, we'll continue with 1.6 on the composition of functions on page 138 in our 1.6c video.